All right, next two sections, we're going to focus purely on the algebraic aspect of it in terms of setting proportions up and solving. So there's a bunch of theorems, and we're going to go over how to solve these algebraically. So the Proportionality Theorem says that you have two lines that are parallel. So we're going to break these up into proportions. So we're going to be consistent in terms of how we label them as well. So you can do AB to BC. So that's this to this would match then with this to this on the other side. So you just want to make sure that when you are labeling, you're being consistent. Whichever way you choose to write your proportion, just make sure that the two match up on both sides of the figure. So let me just jump to a actual example because it's a little easier to see it so I can write more on it. So we know PT is 7.5, TQ is 3, SR is 2.5, and we're looking for this. So we see that these two are parallel. This is the key. So if you see that these two are parallel, we're going to make a proportion. So we're going to stay on one side of the figure. So PS over SR, and we're going to match it on the other side, is PT over TQ. And let's plug in. PS is X, SR is 2.5, PT is 7.5, and TQ is 3. So you're staying on the same side one at a time. So when you cross multiply, you get 3x equals 18.75. X is 6.25, which is your PS value for that. Same problem, if I just erase these numbers now. So PS is now 12.5, SR is 5, and PT is 15, and it's a 15. And we're finding TQ. So same proportion, 12.5 over 5 equals 15 over X. And then you're going to cross multiply. You get 75 equals 12.5X. And X comes out to being 6, which is your TQ value. So this entire section, and this is going to continue in the next section, the key is you have to be consistent when you're labeling this stuff. Okay, because if you're choosing just to bounce around the figure, you're going to find out that you don't have proportions that actually work out. So this particular theorem talked about it had to be parallel first, and then we were able to create the proportion. This next theorem, which is the converse to that, flips it. So now we have the proportion, or we can create the proportion, and then we want to show that the lines are parallel to each other. Okay, so it reverses. So if this proportion is true, then we can say that the lines were parallel to each other. All right. So we're going to jump ahead here, skip these guys right here, and we're going to jump right down to the mid-segment theorem. So the mid-segment theorem, think mid-segment. A mid-segment of a triangle is parallel to one side of the triangle, and its length is half the length of the other side. Okay, so JK right here. First of all, J is a midpoint, K is a midpoint. If that is the case, then JK is parallel to FG, and not only that, but JK is half the length of FG. Because it can't be the same length, because you can see that it's already smaller, so it's got to be half the length. All right, so it says in the figure, XY and XZ are midsegments. So that means if X is a midsegment, then these are congruent. If Y is a midsegment, then these are congruent. So first things first, this bottom part right here is equal to 13. If that was just split in half, then I have 6.5 on both sides. So let me get that out of the way. All right, part 2 now is asking these 3 bits of information. So it says XZ. Well, XZ is right here. That's what I'm looking for. Well, if you look at that right here, and you look at this figure, right now that is a parallelogram, which means that the opposite sides are congruent to each other. So if this is 6.5, then this side has to be 6.5. Okay, it is also, I'm going to write also, XZ equals half the length of RT, which would be half of 13, which again is going to get you your 6.5. So either way you look at it, whether you look at it in terms of parallelograms or whether you look at it in terms of it's half the length, same idea on both sides. All right, for the second one here, so it says ST. Here's ST. Well, if we look at the same figure, but now we're looking at this side right here. Well, that's 7. Well, again, parallelogram, which means opposite sides are congruent to each other. So ZT is also 7. Well, though, if Z is a midpoint, if that's 7, then we know this is 7. So ST is made up of 2 7s, which is equal to 14. So ST is 2 times 7, which is 14. The other way you can look at it is ST equals 2 times XY. And if XY is 7, that's also going to get you 14. So either way you look at it for that particular one. All right, now, in terms of this angle right here, think all the different angle pairs we've gone over. If I extend these green lines a little bit, these are 2 parallel lines cut by a transversal. This is the angle I'm looking for right here, which is actually congruent to that angle because they're alternate interior angles. So alternate interior angles are congruent. So there's a decent amount of old material that's going to come back into each of these questions, and it's all lumped into the same type of problem. All right, let's try another one before we get back to proportions. So let's see if we could fill some stuff in here. All right, so if we focus on, we have lots of midpoints going on here. If we focus on this figure right here, which is a parallelogram, if this is 9.2, then this is 9.2. That's congruent to this, so that's 9.2. I'm just filling in numbers right now. In terms of corresponding angles, this is 82 degrees, which means this is 82 degrees because opposite angles in a parallelogram are congruent. That other side, if that whole thing is 15, then half of 15 is 7.5, which means this is 7.5 right here. Okay, so let's see. DE we just found to be 7.5. DB we just found to be 9.2. And FED we just found to be 82 degrees. So it actually helps to fill the entire diagram in first and then go back and see what's being asked of you. All right, let's finish it off with finishing with these proportions. So now we've got multiple lines that are parallel. And again, we're just being consistent in terms of how we go about setting up our proportions, if we're able. So it says find the value of the variable. So the nice part about it is we would do 3y plus 8 over 5y minus 7 equals 6x minus 5 over 4x plus 3. But the problem we run into is there's 2 variables. Okay, so that's a problem. So that's our issue right there. So we're going to stop. Okay, so what we're going to notice, though, is you see these marks right here. And you say, well, what do those marks mean? They mean equal. So MP is equal to PQ. So 3y plus 8 is equal to 5y minus 7. So 15 equals 2y, which means y is 7.5. Now, if we think in terms of proportions, if those 2 blue marks are congruent, and these lines, you have 3 lines here, if they're parallel, they're going in the same direction, so they're not turning, they're not rotating, they're not doing anything. If those 2 segments we said were congruent, then that means these 2 have to be congruent as well. So JK is equal to KL. So 6x minus 5 equals 4x plus 3. 2x equals 8, which means x is equal to 4. So you actually, in this particular one, not always, but in this particular one, you don't even need to set up a proportion, okay? Because it's not going to help you. You're stuck with the 2 variables, and you're not going to be able to get rid of them. All right, so let me show you where the proportions now come in to play. Something like number 8, okay? You see nothing that's congruent. You see lines that are parallel, so let's just write it out. So we've got, all right, so we have 7x minus 2 over 4x plus 3 equals 8 over 8. Now we're going to cross multiply. 56x minus 16 equals 32x plus 24. You get 24x equals 40, which means x is 1.7 for that. And then for 9, this is like 7. So if you see these 2 are congruent to each other, then these 2 have to be congruent to each other. So 2x plus 1 equals 3x minus